Let's look at how we can use the compound interest formula to answer questions linked to compound interest. So the example says, calculate the final amount and the compound interest for a loan of £125,000 for 15 years at a compound interest rate of 4.8%. So using our formula, we have that the final amount A equals to the initial amount, or the principal P, multiplied by 1 plus R, where R is the compound interest rate, to the power of n, where n is the number of years. So in this case, to work out the final amount, we would just need to substitute the relevant values into this formula. So we have that the final amount A equals to, so the principal is the initial amount, which is £125,000. So we write that in. Then we multiply by 1 plus the interest rate. And so in this question, the interest rate is 4.8%. We can write that as a percentage or as a decimal. So if you write that as a percentage, we have 4.8%, all to the power of n, where n is the number of years. So in this case, we have 15. And if we substitute this into a calculator, we should find that the final amount A equals to £252,539.47 if we round up. We wouldn't round down in this case because that would leave us with a very tiny amount that we would still owe. And so within these sort of questions that involve money, we tend to round up. But again, it always depends on the context of the question. Now, to work out the compound interest, we just need to take away the initial amount from the final amount. So in this case, our calculation would be that the compound interest equals to, so the final amount we just worked out was £252,539.47, and we take this away from the initial amount, which was equal to £125,000. And working this out on a calculator, we should find that we end up with a value of £127,539.47. And so that's the compound interest applied to this specific loan. We can see after 15 years, the initial loan has more than doubled in value in terms of what is owed at the end. Let's look at a final example. So the question says, calculate the final amount and the compound interest for a loan of £8,000 with a compound interest rate of 2.5% for 30 months and 3.5% for a further 18 months. The first thing we should notice is that the time is given in two separate intervals, and these are in months. So we first need to convert these into years. To convert 30 months into years, we just divide by 12. So 30 divided by 12 gives us 2.5 years. And similarly, to convert 18 months into years, we divide by 12. So 18 divided by 12 gives us 1.5 years. And now for 2.5 years, we have an interest rate of 2.5%. And for 1.5 years, we have an interest rate of 3.5%. And so essentially, to work out the final amount, we use the formula that we looked at before. So the final amount A equals to P, which is the principal, multiplied by 1 plus R, which is the compound interest rate, to the power of n. However, in this case, since we've got two different interest rates for two different time intervals, we're going to have to split this formula to help us work out the final amount. So to do that, we do the following. So the final amount equals to the principal, or the initial amount, which is £8,000. And then we multiply by 1 plus the compound interest rate. So for the first 2.5 years, we had the interest rate of 2.5%. And so if we raise this to the power of the number of years that applied for, that was 2.5 years. And then we're multiplying by 1 plus the second interest rate. So for the second interval, 1.5 years, we had the interest rate of 3.5%. And this was applied for 1.5 years. And so substituting this into a calculator, we should find that the final amount equals to £8,960 and 0.44677 pence. Now we need to round this value up since we don't want any amount to be left over in the loan that needs to be repaid. So to the nearest penny, the final amount would equal to £8,960 and 5 pence. Finally, to work out the compound interest, we just need to calculate the final amount minus the initial amount. And so in this case, the compound interest equals to £8,960 and 5 pence minus £8,000, which gives us an answer of £960 and 5 pence, which is equal to the compound interest.